Start recording. Okay, so like I mentioned, if you are struggling with knowing where first of all, I would encourage you, right, to to copy the link and keep it somewhere accessible to you because you might need to go in there because that's where I'm going to be dropping all the Jupyter notebooks. But in case for some reason you you can't find it or you don't know where it is, right? Let me show you where to find it. So it's going to be something like this. So you get in here. This is what my screen looks like. I'm not exactly sure what it looks like in the student view, but this is what it looks like for me. And I hope you all can see my screen. So you have stream, you have classroom, you have people, and then marks, right? So you go into classroom and then you see a bunch of things. I have the final projects, and I'm going to talk to you about that a little bit. And then the syllabus, you find the syllabus here, and then under resources, right? If you click uh, resources general and you open it, that's where the location of Jupyter Notebook is in the description for general resources. That's it here. Location for Jupyter Notebooks. Once you click it, it's going to open up. And this is what it looks like. So for today, we have for week one, week two, and this is week 3A and week 3B. So that's what we're going to be dealing with today. So that's how this is organized and set up. And I did mention the other part, right? About the final projects. So I'm curious to know if there's any problem, any challenge with that, because I put together that whole thing and I put a copy. I made an announcement. So if you go to stream, I have that announcement made here. So you're going to see it. And then I went to each of your groups and I also dropped um the announcement along with the folder that has the instructions of what you're supposed to be doing. And I think I also went into the announcement channel in Discord, beside going to your individual groups to drop all of that. So my hope is that everybody has gotten the information and you know exactly what you're supposed to be doing as a group. And if you notice, I crafted it in such a way that everybody gets to participate. And one of the things I mentioned, the entire project is going to be 30 marks. 10 of those marks is going to come from your presentation to this class. And myself or the co-instructor would not be responsible for giving you the 10% mark. So you're going to do your presentation and there will be some kind of pool. And the majority, if they give you one or they give you two or they give you 10, whatever the majority is, that would be your grade for that part. And then the second part, the second 10 will be just your class review. So at some point, I'm going to send like an Excel sheet to everybody, beside you including it in your two-page report, right? Telling us what everybody did. I'll send an Excel sheet so that you can just put the names of everybody in your group and then um, go ahead beside them and assign a grade to them between 1 and 10. And the third column will just be, your sentiments about that person. And the reason for doing that is I need everybody engaged in the project. That would help us and help everybody. So essentially, you're working like a project data science team trying to solve a problem. So, any questions on that? Questions? No questions?
Okay.
Yes, sir.
Um,
Yeah, was someone trying to say something? Okay. It doesn't seem like they're trying to say something. So, Um, I want to think we resolved that. So I'm going to go straight into what we have for today. Just give me 1 minute. Give me 1 minute. I need to open up these folders.
Hello.
Yes, go ahead. Someone was saying hello. Were you looking to say something?
Please, sir, I'm sorry, please.
Okay. All right. So, today we're going to actually be focusing a bit on
Excuse me, sir. Excuse me. Sorry to throw you back. So I have the a question is on the assignment.
okay.
So I've looked at it and considering the deliverables, sorry, key dates.
Yeah.
So on the 26th, are we going to do sort of a proposal to tell you what we are going to work on, or just we are going to present the data set? So that's number one. Then on the progress, what will it look like? Is it for us to do maybe a mini presentation on how far we have gone? Because I understand that the final presentation that we're going to put everything together and do a class presentation. But that of July, is it sort of where you propose, this is the data set, this is the details of what you're going to, the questions you're going to answer, with regards to the data set you are going to work with?
Yeah, both excellent questions actually. And that's a gap I probably didn't fill in very well. So, um, and one of our questions is when you propose your data set, are you just going to say, hey, this is my data set, or are you going to put some flesh around it to say, okay, this is the data set and this is what I'm trying to achieve? I would probably say because so you all have a lot going on, right? And I don't want to put additional burden on you. So, but if it's possible, just give me like a half page, right? This is the data set I want to use. This is why, and this is what we are trying to achieve. So a half page will be okay.
Okay, sir,
So
thank you.
yeah. And then for the second part, now if we are going to do which I said also in a typical class that is multiple weeks, right? I will be like, okay, let's go through because one of the reasons why those progress reports, right, are very, very essential is almost like why you have agile, for example, in project management, right? You don't want to keep moving in the wrong direction. So one thing you want to do is to you go to your sponsor, tell them what you're doing and where you are, and then they will check and make sure that it aligns with what their goals are. But frankly, we do not have the luxury of time. So what I will say, that checking will probably be a an opportunity for everybody to say, check, we're doing well, check, we're doing well. Maybe during I think that 26th is a Saturday during the class, right? I'll just call on the groups. I remember we are like 10 groups. So it's that can consume a lot of time, you know. So that's why I don't want to I just want to be able to know that everything is going well. But if you've run into any serious problem at that time, I just want to be able to know that. That's all. So it wouldn't be a real elaborate progress type report, but it would just be, hey, we are doing okay, or we need help at this point. And sorry, if you're not speaking, please just turn off your mic so that you don't distract the class.
Good afternoon, Prof.
Good
Good
afternoon,
afternoon,
sir.
class.
Yes, sir.
Concerning the group, I don't know where to find the list of members in the group. I'm not sure how the group has been established. I wrote you yesterday concerning the group. I don't know where, I can't find my name anywhere on a group, so I'm not sure how it was.
So type in your name in the chat. I will look at it. Because I
Okay,
don't
Prof.
know, were you here last week?
No, last week I was not online. Yeah, I didn't follow the live last week. I had a network issue.
Okay. But what I would strongly recommend is that you check the video for last week because all of that information is there. But just put your information there so that I can go back and figure out if you're in a group. I'll just transact with you. Just put in your
Okay.
name there. So Peter, Mr. Peter.
Yes, Prof.
Oh, you were the one talking?
Yes, it's Peter talking now.
Okay. Sorry about that. Okay, Christian.
Yes,
Hello.
good.
Yeah. Yeah, go ahead, Christian.
Hello, can you hear me?
Yes, I can hear you super well.
Okay. So, okay. So, good afternoon.
Yeah, good afternoon. Go ahead. Go ahead. Seems like your reception is
All right.
bad.
So, I was just wondering because we've also had other. There be individual submissions for this group assignment. Can you hear me?
Yeah,
Can you hear me better now?
I can hear you. Yeah.
Okay. So I was saying that. Okay. So I was saying that we have had other group assignments in the past.
Yeah.
Some of those assignments we had situations
Sorry?
where
Sorry, Christian, your reception is super
do the
bad.
group leaders submit some. Now I'm wondering other group members on end, okay, from their own platform. So I'm wondering whether this particular course will be the same thing.
No, so you as a group will submit just one thing. Trust me, like just submit one thing, you
Wow.
know. Yeah,
Is it better?
yeah, it's
But I can
better.
hear you
Yeah, it's
so
better. I get
clearly.
I get your question. I get your question. The thing is, we can't hear you. There's a break in your
Hello.
Yes. So, Christian, there's a break in your transmission, but I understand what you're saying. You're asking, and if that's not what it is, you can just chat us up, right? You're asking if, based on your past experience in group work, that individuals had to submit their own, reports or something. So I'm saying because we have serious time constraints because we still have a lot to cover, just submit as a group and it's just 30% of your mark. All the other 70, you have an opportunity to exhibit your individual talents there. So we're going to just be doing 30% with that. So Isaac, I hope that helps. Christian, sorry for jumping suddenly. But if you still have concerns,
No,
just
sorry. What he was trying to say, we have a group lead. He or she will submit on behalf of the group. Then we'll capture the names of the group members. Then the group members will now submit their names with the group members. That is what they submit in time past.
No, I don't understand.
So now
The group leader will
yes.
submit a report on behalf of everybody with their names, and individuals would also submit.
No, individuals will now write their group name, and their names and submit.
What do you mean their group names and their names?
That is group two. Group two.
Okay.
The group two, you write group two, then you capture the names of the people in group two and submit. You don't have to submit the report or the slide again.
Oh, I see what you mean. Oh, yeah,
Yes.
that's fine. That's fine. That's probably more a Google Classroom logistics issue. So that's fine. Everybody can do that, and then the group leader can submit the final report for everyone. So if that's what you're saying, that's fine.
Yes.
Yeah. So, Mr. Isaac.
Hello, sir.
Yes, sir.
Good afternoon.
Good afternoon.
Yes, sir. Sir, I think the other day we met, We're on the group discussion on the Discord.
right?
Discord, yeah. But he wanted us to do the GitHub setting
Yeah,
or the GitHub profile, yeah, for each of us.
right.
And then I don't know whether that thing has been done or not. And if no, when are we going to do it, sir?
Yes, we are going to do it today. So that will
All
be
right,
done
all right,
today. All right.
all
Thank
right.
you.
Thank you very much.
All right. Okay. So yeah, Isaac, you can bring down your so I'm going to go ahead and just get us started. I'm going to do a bit of what we have going on here, and then would actually go into some GitHub, the GitHub training that I mentioned. So let me see. So, like I mentioned, we're going to go into deep cleaning today. Last week, we took a bite of some of what we are supposed to be doing this week, right? Which is, trying to, clean up data and all of that. So we're going to make additional progress today. So I'm going to go ahead and share my screen. Am I sharing my screen? Okay. Let me perhaps just 1 minute. Close this down. Open this. Yeah, I have 1,001 things on my screen. So this is week 3. So let me hope. I hope you can see my screen. If you have difficulty seeing my screen, please let me know. So,
Yes, sir.
okay,
That's
so
it.
yep. So we're working on week 3, and that's data cleaning and exploratory data analysis. And the learning objectives today will be to apply data cleaning techniques such as missing values, outliers, and data types, right? And like I mentioned, we started a bit of that last week and I particularly shared 2 videos, right, of someone actually working on doing complete, cleaning of data sets. And I think it was a 38 or so minute video, and then the other one was about 2 hours. You know, the guy is really good. So if you missed that, go to week 2 and then check out the videos that are included there. That would do you a whole world of good. So we're going to complete the data cleaning part and then look at exploratory data analysis, where you are essentially looking, doing, a check of your data to actually understand your data before you begin to do anything. So, after the cleaning, we'll conduct exploratory data analysis using visual and quantitative tools, your statistical tools, to understand maybe the mean, mode, median, those kind of things, percentiles, quantiles, you know, all of those kind of things. And then we'll use data distributions, relationships, and correlations. And then we'll use libraries like pandas, Matplotlib, and Seaborn for the exploratory data analysis. So like we know, like pandas is essentially used to manipulate data, clean data, and do all of those things, right? To help get your data ready. And then Matplotlib is the primitive visualization tool, right? In Python, while Seaborn is the more advanced visualization tool that we have, and we're going to see it here. Now, so data cleaning is the process of correcting or removing inaccurate, incomplete, improperly formatted, or duplicated data. Again, like I mentioned, we dove into that yesterday. So for this particular section, we would apply several data cleaning techniques. such as handling missing values, fixing data types, detecting outliers, and preparing data sets for analysis. And we do it in a project-based way. So some of these we looked at last week, particularly str.strip. You had the left strip, right strip, your regular strip, and then this is another one, drop underscore duplicates, which you use to remove duplicates, and then to correct data types or change data types, you have this. And then to handle missing values, we have fill now and drop now. So here we start by loading up some data set, and the data set we are loading is some kind of data set that's actually on GitHub, right? And it's a case of the Titanic. So in the Titanic, a whole bunch of things happened. People died, but then they had collected data about all of the people, their name, their sex, their, their ticket number, the fare they paid, like how much they paid, all of that. They collected all of that data, and then things like the cabin in which they are, all kinds of things. And then they were also trying to look at the passenger class, and whether they survived. So you survived or you did not survive. So it's almost like one of those Boolean values, right? It's either 0 or 1. You either survived or you didn't survive. And these are all different types of data. And then the passenger ID. And you find out that all of these different data sets have different ways that you handle them. If we have the time today, I want to take us to how you actually handle what do you call it? Calendar dates and time, right? In calendar dates and time, so today in US calendar methods, right, it's something like 07 slash backward slash 19 backward slash 2025. Now, how do you deal with that? There are specific ways in which you deal with data sets, right? So being able to do those conversions so that the computer can read what you're putting in there is a definite skill that you need to do your data analysis. So we're starting from here. First of all, we've put in your URL is equals to, and then you just copy the URL of that data, put it in quotes, and then you use pandas, and the method here is pd.read underscore CSV. That's what you need to be able to pick this up. And you have your parentheses, and then you just copy your URL. You can copy this directly, or you can copy, but since we've already defined it, you put in the variable here, and then when you run this, you will get your head. So for example, normally it will give you 1, 2, 3, 4, 5, 5 of, but I can decide here, I want to make it something like, I want to see the first 10, right? It will give me the first 10. So depending on what you want, if I want more of that, but the standard number of data sets it will give you is usually about 5. So by just pulling in, so the other thing is I might want to know, remember this is your index, right? This is not part of the data. It just shows you how many rows we have here. So I might decide to say, okay, you know what, let me see how many colons there are, right? So instead of head, I've seen the beginning, let me see the end, right? And I click tail. So you can see we have 890 people that were on that sheet. So that's how I'm able to do that. So you can curate that data to find out all of those details. So that's you beginning to play around with your data to actually see what's in that data. So next thing, you want to understand, besides the preliminary understanding of the data, you want to also look down on that data and find a couple of other things. Remember, you've defined your data. Your data is DF, right? So that's the variable. So I can come here and then I just say, okay, let me look at what's in df.info, right? Which is almost like what you call df.describe, where it will just give you look at different aspects of that data. So you do that. So that's what you use here, right? And then you run that, and this is what you have. So it gives you like a summary of everything that's going on. And then this also gives you, right, that data frame is null.sum, right? So this is where we have all the missing values. That's what this second line does for you. It gives you all of the missing values. How many passenger IDs are missing, a lot of the, was it 800 or 800 and 890? We have about 177 of them where we don't know what their ages are. We don't know some of them, we don't know what cabin they were in. So we did a bit of this last week. You can still look at it and particularly look at the video that I sent us. And this is where you begin to handle your missing values. How do you look at your missing values? Now, the first thing is, and I would strongly think that we all have some sound understanding of Python, because this is one of those commands, right? So you can see if this is like an if statement right here, and in is also one of those reserved words, right? Essentially what it's saying is if age, remember what your age is, right? This is age is one of the columns, right? And remember from last week, you can literally extract one of the columns and focus on that column. But what this is doing is if age, which is that specific column, is in the columns. So these are our columns. These are our rows, horizontal, and these are our columns. So essentially, you're checking if A in df.column, right? So what you're saying is df, once you put this in quotation marks, you are literally extracting or separating everything on in age, right? Equals to, and then you still put the same thing, but this is the method that applies to whatever is going on here. And then your age. So essentially you're filling in filner dot filner. You're trying to fill in, and then you want to use the median, right? The median of all of the scores there to fill in anywhere we have missing values there. And why do you do that? Remember, I think in the last week test, right? There was a particular place I was asking, why do you, um, um, when you have a missing value, what does it do to, for example, that specific column, right? Okay, let me use an actual example. So let's say you have 10 children, right? And they are on an Excel sheet. And then their ages are 17, 14, 13, 16, and all of that, 10 of them. And then you happen to have 2 or 3 missing children, like missing, the data happens to be missing the age of 3 of them. If you take the average, like you're looking for the average, that average will be distorted. That average will not be correct. But somehow you still have to continue with your data analysis, right? So what you essentially do is you take the average of all of those, all the kits, right? Take the average of the available data, and then which is the mean, and then you use that mean to fill in those missing gaps. That way the data is not skewed or distorted at all. So in this particular place, in this particular age, right? And then there are all these measures of dispersion, like your mean, your median, and your mode. Sometimes you have to be careful. So for example, if I have a wide range in terms of, I have people that are say 2 years old, and I have some people that are 80 years old, right? And I go use the mean might not be the correct thing to use because there's a wide dispersion. So that's why, for example, they are using something like median here. So it's going to be somewhere close to the middle. So same thing here. Impact is one of those columns, right? You do the same thing with impact, and then in the case of the impact, you use mode, and mode is how many times a particular data set, repeats. That's what was used, what they used to fill this. And then what else do we have here? Yeah, in this particular case, look at if cabin in this dot column is equals to cabin. I think they dropped cabin, decided to drop cabin. And what else? Missing values after cleaning. Show missing values summary. And then, yeah, so after doing all of this, right, the next thing was to check and see where you have missing values, because you've done all of that, right? Because if there is still additional missing values, then you probably need to do additional work. So this is more or less a check to make sure that there is no more missing values. And if there is, then you can target that specific missing value, and all you're using. Yeah, go ahead, Christian.
Okay, I'm just hoping that you're going to hear me this time around because I'm getting confused. Can you hear me now?
Yes, I can hear you.
I'm sorry, I'm a little confused with this code.
Yeah,
If a
yeah.
in df.column. What's the difference between using an if here and using a for here? For age in df.columns, for embarked in df.columns. What's the difference? What effect will it bring in the distance? Because I'm a little confused why
Yeah,
if was
so
used here.
what does for do for you in programming? That's the first thing you ask, because here what you're doing is you're testing a proposition, right? I'm trying to check if this is in here, if this is happening, do this. You see what I mean? That's why you're using if.
So when you say if age
Mhm.
in df.columns,
Yeah,
what does it mean? Because there is definitely an age column.
yeah.
Okay, there is an age column, so that is definite.
Mhm,
So when we are saying that if age
mhm.
is in the df column and the age here is in what do you call it now, in quotes, so meaning it's a string. So
Yeah.
that's why I'm getting seriously confused. I don't know how you can explain it to me.
What do you mean by age is a string though? Because remember what that age is talking about. The age is not targeting any specific string, it's just talking about the colon, right? Because what this is trying to do is essentially test for if there is a gap, right? If there is a missing value, right? Fill it with this. Does that make sense? Because what we are essentially
Still
doing right now
confused,
is
but let me not keep
we're
the let me not keep the class. Go on, sir.
no, no. I want everybody to understand what's going on, because it's what you're asking is a programming question actually. So let me try what you're saying. So go ahead for go ahead. Just give me what the idea you were trying to come up with. Let's try.
No. What I'm saying is that just
Mhm.
replace the if with for.
Okay.
The same thing, but just instead of if, use for.
Okay.
That is what I thought. So that's why I'm trying to understand what the difference is now that you're using if.
Excuse me, sir.
Yeah, go ahead.
I think when you are using for, sir, you are trying to iterate. You are trying to loop through your program. You want it to loop and test different conditions. But this one is just checking
Yeah.
whether there is.
So
So,
both,
for is for iteration.
yeah, four would four, in fact, both of them would iterate, because you're just saying, how do I explain? I'm trying to figure out a better way to explain it. Almost both of them, right, would iterate. Um, mm, at the end of the day, I think the because I'm trying to remember. I'm trying to remember. Um, to your point, right? For so, for example, we have something like a list. This is equals to, and then one, two, three, four. Um, so if we have something like this for uh vehicle, for example, in vehicles, in vehicles. So I make this, for example, vehicles, right? So I don't know who it was that was talking about. What was your name? The last person that was talking about, because this is what you're talking about, right? A lot of times, this is, say, we say print um, capital V, print
Yes, what
vehicle.
you're doing
Yeah,
now is the iteration. Yes, so that's
exactly.
an iteration.
Yeah,
So
this would iterate. Yeah,
okay.
this you're just looking for something inside. Does that make sense? And I think it's Peter also that was asking. Huh?
No, it's Christian that asked. Then
Okay, it's
some other
Christian.
person now made a contribution. Yes.
Okay, yeah. So again, this is essentially a programming issue, and personally, that's why I was holding the programming class earlier. If there are programming issues, or else there are a lot of things when it comes to programming that are not very intuitive like that, you know, and it will be helpful to just go through that. Because once, I think it's Christian, right? Once you go use for, all of a sudden you begin to iterate, even though there are times you can use if to iterate around things, depending on what you write here as your comment. But essentially, if you're looking for something inside of something, you're going to be using your if and in. Because essentially what you're doing here is you're checking it if something is inside something, and then you create the condition of what you are looking for inside that particular thing. So same thing here. Um, fixing the data types. So in this particular place, all we are trying to do right now is to try to survive. Let's go back and see what we have in survived. Where is survived? Yeah. So we have 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Where are we fixing the data types? So you have your survived, which is one of the columns, and then you're trying to convert them to category so that the system would be able to understand those specific data types. And then in this particular place, what you're trying to do is actually convert the tickets to strings. Let me see what we have as our tickets here. Okay. So you can see this is a mix of numbers, right, which the system might not understand. And if you go check this, right, the data type is probably not going to be clear to the system. So to be sure we know what is here, you want to convert that to string so that the system just sees it as string. And then when you run your df.d types, right, your dt types or d types, right, what this method does is essentially help you check all of the values that you have here, which is essentially your column names, to see what data types they are. So you can see, for example, survived, right, has been converted to category. And then you have your P type to category too. It's changed it to category. Your name is still an object, all of this. Your age is float. And the other thing that was changed is your string, your ticket, which is the ticket type. So essentially all you're actually doing, right, is preparing the data so that the system would understand what's going on. Question. So, so the next thing is, of course, you want to detect and see if you have outliers, because the problem with outliers, right, is that it will skew your data. So let's say, for example, you're trying to analyze the data of 100 people. 100 people, all of them, right, make, say, $1,000 each, or between $1,000 and $3,000, right? 99 of them make between $1,000 and $3,000. And all of a sudden, the 100th person is a billionaire. If you take the average of that data, the average is going to not be, it wouldn't even fall in within the 3,000. The average is probably going to be somewhere still in the billions, right? Which would not make sense. So sometimes you want to find out whether those outliers are there, and then you try to figure out what to do with the outliers. So, but this will take you a bit of time to understand. So if you look at this, we run this code, right? Essentially what we are using is a block plot. We're using Seaborn, which I mentioned is an advanced data visualization tool within Python. And we're also using Matplotlib, particularly the PyPlot one. So that's why it says, and this is also just summarizing it, right? Using an alias so that we can use that alias and not write out our Seaborn completely. So we start with the box plot, and then you use your Seaborn, and within the Seaborn, what you want to call up is your box plot, right? And I want to focus on the fare that people paid. So, and I use a variable to declare, this particular, in other words, my X, my colon, the fare colon, right, is equals to X. And then these are just rudimentary to help understand data, right? You're just putting a title, which is what creates the title here. And the show is actually to make it show up. And then the next thing is to remove the extreme outliers. So essentially you're asking, like, everything within the lower quantile, which is the lower 25%, hey, I want to define it. So your DF, which is your data frame, which is what we defined at the beginning, which is our DF, which is our data. And by putting these square brackets and the open and close parentheses on fare, you are literally extracting that column, or you're trying to say, hey, I'm focusing on that column. And then dot quantile essentially is saying, hey, this is a method that wants to look at the quantile day. And then you can choose what quantile. You can decide to be like, oh, I'm looking at the 90th quantile, or I'm looking at the 25th quantile, or I'm looking at the 50th quantile, all of that, right? So this is my Q3 and this is my Q1, right? So what I want to do eventually is I want the data that I want to fall within Q3 and Q1. That's where I want to, and if I do that, what happens is that I'm eliminating everything before and after it. So I'm just creating a boundary. And then to actually get my lower quantile, which will be my Q1, which is the 0.5, minus 1.5 times this, and that's how you define like your upper and your lower quantile. Let me see, Q1 minus 1.5, and the 1.5 is arbitrary. You can actually choose how far in and out you want it to go, right? Because that's how you define. Uh, is this a question? Yeah. And then you go, the final DF that you choose, right? Look at what you're doing. You use your DF fare, and you're looking for anything greater or lower than the lower quantile, right? And so you're looking at, for those of you that were taking the Python refresher course, if you remember, right? This is, you're looking for your and so this has to be true. What is happening here has to be true, and this has to be true for it to happen. So everything greater than or equals to the lower quantile, and everything less than or equal to. So essentially, you're creating a bound between those two points. So everything between this point and this point, right? Especially here, I can decide to change this however I want, depending on how far I want this to be denominated. Because, so for example, if I had this point, right, somewhere that I don't want, or further in, and I still want to eliminate it, or this is further out there, it will determine what I choose to use as this coefficient. And then you print it out, and that's what we have. And then when we did the summary, you run the summary where you're actually describing, and you want to include all of your data. This is what you have. Again, if you're looking at this for the first time, and which is why I'm providing these slides, right? Go look at it, and if there are points of discussion, we can always come to what do you call it, to Discord and talk about it, even specific piece of code, right? And again, there is no one way to write your code. There's no one way to write your code. I can come up with two or three different ways to write this code. But the most important thing is you sit down and you ask yourself, what am I trying to achieve? There has to be a particular thing you're trying to achieve, which will determine what you begin to do with your data. So I just put this here, right? If you have your own time, you can just play around and try this. Some of the things you could do, and some of the tasks you could do with this piece of data. This is a Boston housing data, run it. And again, you can just use this same code here and try to run this data. Of course, you're going to have to be changing some things, right? Depending on what specific columns you have, what kind of rows you have. But as if you're someone that is not already familiar with data science, the best thing will be use the existing code that is here, right? Use a completely different data set. One of the things it will do for you is to force you to begin to understand what's going on with the various rows. Why? So, for example, some things are going to change, like your survived, right? Because this is not going to have survived, there is going to have something else. Things like how do I fill in, or how do I actually deal with outliers? All of those things are going to change. So definitely try this. This will be helpful to try.
Hello, sir.
Yeah, go ahead.
Can I ask a question?
Oh, absolutely.
Yeah, my question is this. This code, are they statics or one can create it as a data scientist?
Oh no, you can create, absolutely, you can create whatever. But I said that to mean that personally when I started learning, I essentially started using other people's code, because the first thing that would make you I describe it just like language. One of the easiest ways to learn language. So I did French in high school for like 6 years, right? I still can't speak French. I can write some French, I can read French, but I can't speak French. So, but somehow, which is the problem with the way we learn language, we want to go learn all the syntax and begin to construct things ourselves. But reverse that and think of how children learn language, right? Nobody teaches them anything. They just get immersed in the environment. And then the next thing you hear is ba, 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 and then they start speaking the language. So if I picked up a Caucasian kid, right, a white kid from America at birth, three months old, and the person goes to live in Africa, say within the Yoruba community or the Igbo community or the Efik community, for example. By the time the child is 3 or 4, they will be speaking the language. And the reason is just because of immersion. So some people want to learn a specific language, they go to YouTube and start watching a movie or keep watching movies and everything around the subject they want to learn. And before you know what's happening, they are able to speak, or they start by hearing what's going on. And I want you to apply that same analogy here. As you keep looking at these things, initially it would not make sense. There are still some piece of code that I'm, constantly confused about, right? But as you keep looking at them and you keep looking at them, all of a sudden it begins to make sense. And then the second thing, which is why I like Jupyter Notebook, you can pick up anything there, create a cell under it, and try to write something yourself and see what happens. It will give you some errors. You read the errors, you know. But again, my point is just keep manipulating and playing around with the data. But the first place to start, I can tell you, is use other people's data and then figure out what's going on there. Additional questions? Yeah, because again, sometimes so if I was coming to teach here, right, and I decided to start writing my own piece of code, then we would not finish, wouldn't finish this. We would never finish this class. That will be one of those, um, so exploratory data analysis, which is your EDA, right, involves summarizing the main characteristics of the data, often with visual methods to better understand its structure, um, and inform modeling decisions, right? So an exploratory data analysis is almost like what your typical data analyst will do, where you are, printing out doing a visualization of the data, looking at different aspects of the data to see patterns, to see if there are any trends, see if there are any, um, um, anomalies, even after you've done your deep cleaning. And then some other things that you do is when you have your clean data, now that's when you begin to formulate your hypothesis, right? What's your hypothesis? It's your hunch of what is going on with the data. You can't prove it objectively, but you're like, okay, this is probably what's going on with this data. And this is, if we do this, this is what we think we are going to get, right? And then after that, after you've done that, that's what your EDA helps you do. And then when you go into the modeling phase, you can begin to test those hypotheses. It's almost like what you do, what you do when you do your typical research. And then the other thing that you do with EDA is essentially identifying the correlations and the outliers if they still exist, you know. And sometimes it's an iterative process because you might do a bit of your EDA and then you go back and you want to go play around with the data and clean up the data or do additional or you might just realize some of the columns based on what I want to do, some of the columns that are there are actually not necessary and I want to go out and take it out. So this, for example, is a data set, right, around penguins, right? And it's different species of penguins and on different islands, and then the bill, which is the length of the bill, right? This has a specific length of the bill, the depth of the flapper, you know, and the body mass of the penguin and all kinds of things. Let me see what let me look and see additional information about this. So this is, okay, let's check the tail first and see. Okay, this is a different island. This is a different species. But then there are about 343 yeah. Oops, head. So what we are doing here is we are doing a basic exploration, right? let me comment this out and comment this out and see what we see first. So if I comment this out, right, this is the first thing that we see. So we're essentially looking at the different columns. So you can see the different columns, the species, the island, non-null, not null. So this is all we have for the data. So we can essentially see there are three. What did I find here before? I think it's the same thing. 340, 343. So what's this giving us? 344. Oh, I see. Yeah, you know why it's 344 here? Because it's counting the index. And this is probably this probably started with 0. So if you come from 0 to 345, that's how you get 344. So that's the number of rows because the index starts counting from 0. So that's what we have. So next thing, let me see. Let me run this too. So this is where we have our missing values. You are checking. So this is your print command, right? And all you're doing here with this method, df dot is null, right? It's essentially checking to see where you have null values. In other words, where you have null values, right? And if you can see here, the first two things, species and island, is 344. But for this, for bill length, you can see there are like 2, because all of these are non-null, right? For null will be 344 minus 342. Same thing. And then sex is where you have most of the missing data, which is 344 minus 333, which is why you have 11 here. So what this is doing is essentially summing up all of them, with dots df dots is null, is what you use to identify the null values in all of the data. And then dot sum will now sum all of them and then would report it back here. So, and then we run this. What do we have here? This is your describe. We're essentially describing everything that is in that data, the DF, and then we are printing the species dot value counts. So the various species and the total counts. In other words, the number of species. So this is the species, right? Initially, I saw this. If I go do tail, I'm going to see another set of species. So this species Gento, and then head. Oops, sorry about that. And then this is Adeli, but I don't have a full perspective of all the species there. And this is what helps me figure out. So I decide to just put in that thing in square parentheses and put in the column name there, right? Essentially kind of extracts that column. And then what we want to do is we use this method, right, to do a values count. And again, like I mentioned the last time, right, you can literally go in to go check what this method is, right? And if it has any parameters, because there might be some parameters in here and all kinds of things, and it will tell you what exactly this does. Again, why would I just drop something here and it will do something? Because it's abstraction in programming. It's actually a code within Python. All I'm just doing here is just calling that code. And when I call it, it will implement whatever is there. So getting to know what each method does, right, is like learning a language where um, your vocabulary is expanding because you are in touch with the language or people speaking the language over an extended period of time. So the next time you want to do something, right, you know, well, if I use dot values underscore counts, what I'm doing is I'm counting all of the various elements in a particular column. So this is a bit of multivariate analysis. And what are we doing here? So if you remember SNS, which is your Seaborn, and I mentioned to us in week 0, I actually put some videos there that can help you with Seaborn, you know, to get additional insight. But you can see most of what we are doing here is not by itself like complicated. You don't need a special knowledge of Seaborn, but if you want to know more about Seaborn, that might be a good way to look at it. Where to go look. But notice what's happening here, right? Again, we are dropping, you know, any NA. NA is usually when there's no data in that specific column. The first thing we did here is you use your DF, open and closing brackets. All we have done here is to this particular column, we have extracted it, right? And then dot drop now. All we have done with this is to remove anything, anywhere where there is, and what do you call it? Anywhere where there is, you know, missing data. So let's go look at, just give me 1 minute. Let's look at hist plot, right? Seaborn. Seaborn. Let's see what we let me go here. I like going to, oops, stop. Are you still seeing my screen? I hope you're
Yes,
still
sir.
seeing.
Yes,
Okay.
sir. Yes.
All right. All right. So, like if you look at this syntax, right? And you know your histogram is your essentially looking at the frequency of one particular, and that's why, you know, they call it your that's why they call it like a univariate analysis, because you're focusing your analysis on just one variable. And one of the best ways of doing that is to use a histogram, because what a histogram essentially does, it gives you the frequency of a particular thing, you know, with bars, right? So histograms are visualization tool that represent the distribution of a set of continuous data. So, and usually you break these things into bins and they help you understand what's going on. Density plot, all kinds of things. Now, so your kernel density estimation is one of the techniques used to smooth a histogram, right? So look at the parameters. First of all, look at your syntax here. Seaborn dot hist plot. So you put in your data and your XY, which is the key to the data, the hue, semantic data, all of this. The important thing is notice that all of these are optional. You don't have to use them. But again, you might want to come here, understand what's going on, and then you have all kinds of examples. So for your kernel density estimation, one of the techniques used to smooth the histogram. So let me come here. So this is what we have. When you print this, let me see which other data did they use here. DF. Okay, this is your histogram, and then there is also a box plot, which is for this. So histogram, and essentially what you're trying to do is to see how your data in terms of the frequency, right, checks out. And what are we looking at? We are looking at the flapper length, the length of the flapper, right? And we have the different lengths here, right? Which ones repeated most often? You would see it's somewhere around here, 90 something, right? So that's where you have most of. So most of these have very long flaps. The ones that have very short length flaps are very few, maybe about 2 or 3 of them. And this is like your Eskimo, is it Eskimo? Like your short people type, you know, um, the birds that are very small and therefore have very small flaps. But that shows you how the data pans out. Let me try to change the KDE. He said it's for smoothing false, and run it and see how it changes. So this is what we have when the KDE is turned off. So it's not very smooth, and then it also doesn't give us the line that we had, and that's what. So and I showed us that because sometimes when you see some of these things, right? Trust me, there are a lot of these methods I don't know, and I know a lot of people that are really good, way better than me with coding and all of that. There are a lot of functions they haven't seen. But it's just like the spoken language, whatever your language is, there are a lot of vocabulary you haven't run into, but constant exposure to them would lead you in there. And then the second part is where we are doing bivariate analysis, and essentially you're using more, you know, um, two different things. You're comparing two different things. So in this particular place, what we are comparing, we're looking at is the bill, the length of the bill, right? And the flapper length. We want to see how they are distributed here and how they are distributed based on the different, because this is your flapper length, which is your horizontal axis, and this you have your sorry, your bill length is your horizontal, and then your flapper is your vertical axis. So what are we doing here, right? You want to run, do a visualization for all the species of that bird, right? And that's how you do your multivariate analysis. Now, in this case, if you still remember this is our Seaborn, or an alias or short for our Seaborn, and then you use a method that is called scatter plots, right? And again, depending on what data you have here, it can be any other thing. So we can also go out there to go see the syntax of scatter plots, because it's essentially a method. And I would imagine if you go look for the code, for each one of them, you can actually find the code somewhere, you know, because I mean Python is mostly open source, so you should be able to find the code behind this particular method somewhere. So here what we have is we put the data first, and then your X and Y axis, and then your hue, which is what am I focusing on? What am I looking at? I'm looking at the species. I could decide to say, okay, I'm not looking at the species. Let me go look for some other thing. I don't know what other thing. It could be, oh no, this is passenger class. I'm looking for the data on, yeah, it could be some other thing. You could look at your bill. You could look at the island, for example. Instead of species, you can look at the island. Excuse me, maybe we try to see what. Uh-oh, what did I do? Did I run this already? Yeah. So this is how the island is distributed if we're looking at the islands, but this is for the hue, all I did was that I changed the hue, yeah, from the species, and now we are beginning to look at the island, and this is how it's distributed in terms of the flapper length and this in those different areas, right? How the flappers are distributed for in the various islands. You can see in this island you have a mix, and this is just exploratory data analysis, essentially to help you see how your data is distributed. So, and then the other thing is your correlation analysis. So, um, correlation analysis, right, is way more common, right, in machine learning. Very, very common in machine learning. Somehow it's your way of being able to understand the accuracy of your models, right? So what we have here is essentially, okay, if you can see everything on the left column and those on the right column, how body mass, for example, correlates with bill length, flapper length, say correlates with this, and that's all. So, for example, the correlation between flapper length, notice flapper length here, if you go this way, and flapper length is 1. Yeah, because it's a one-to-one situation. Here, same thing. This is body mass and body mass. So correlation analysis, we will talk about it more when we get to, and it's one of those very powerful tools, right, that you use to measure the accuracy of models, essentially. So I don't think we'll go too much into this, but when we get to machine learning, we will talk some more about it. And then finally, this is multivariate analysis. And essentially all we are doing, instead of comparing like what we did in univariate analysis or bivariate analysis, which is two parameters that you're comparing. In this particular place, we decide, you know what, we are going to just go all in and compare everything against everything, right? And that's the power of Seaborn. So all we did here was we used a pair plot, and then again, we dropped everything, right? That is like an empty, um, anywhere you have some missing data, and then you use your hue. Now we are focusing on the species. You can also alter it to any other thing. And then why you have all of these displayed together is because of the pair plot. And then you now choose what your title is, and then you show. And then that's how we get this. Yeah, so all of this is the pivot table, where you essentially put, and you can see what the parameters are here. You're creating a pivot table, and then you list all of the things, right? All of the parameters. And again, like I mentioned, all you need to do is copy this, right? Up to this point, and then just go, and then you can read up about that particular method and the parameters and all of that. Pivot table, there's a whole documentation for it, right? We don't have to go through the documentation. You can read up on it here, right? Pandas allows us to create a pivot table to summarize or aggregate data. This function is important when working with large data sets. And what you're trying to do is to would like to analyze and transform the data efficiently. In this article, we'll see some examples of how this works, and it shows you how it works. And this is your pivot table and how you set up the pivot table. So for example, I have A, and I'm creating this is a dictionary because of the colon, a dictionary with a list embedded in it. And then this is another dictionary with a list embedded in it. And this, right, I can create a pivot table, say for example, A and B, right? And all it does, this is your A, your B table. Wait. A, B. Oh, A, B, and C. Why did this show this way? A, B. Let me see. Oh, okay. Okay, this is what we have here, and this is the syntax, right? And this is what each of the parameters, right? Because all of these things inside the parentheses are your parameters, and it will tell you exactly what they are. And then it will give you specific examples of how you use it. So again, I'm coming from the perspective of, hey, I'm a learner. How do I understand what's going on here? Why do we have this? Because trust me, you're going to have a lot of questions. And what we have done in data science is actually easier when you now go into machine learning, where you have tons of algorithms and so many variables. Now it becomes even more challenging. And when I run into students that have problems with those things, I tell them. So the mindset, for example, for a lot of college students is I go into college and then I read. To get an A, I have to read everything and I have to mark every single line and understand every single line. If you do that with a lot of the emerging technologies, particularly machine learning and all of that, right? It will take you 100 years to learn, and you don't have that much time. And the problem is, before you finish learning one thing, right? Within 2 weeks, there's a new thing that's coming out. So usually you just immerse yourself, learn what you can, and just keep moving. So, um, so I'm going to stop here, and I think we'll take a little break and then come back. All of this is the same thing, the Titanic data set, right? But I was looking at other things, you know. So you can always use that data.
Hello, sir.
Yes, sir.
Hello, Doc.
Yeah, I'm here. I'm listening. Go ahead. Yeah, please go ahead. Are we missing you? Hello? Hello?
Yeah, Doc, please, I would love, please, this your script. Yeah, this your script, please. Help us with, we can reproduce it and
No,
read it on our own.
yeah, so the script,
Yeah, I'm
right?
hearing you, sir.
Yeah, the script is already in the box, and
Hello?
I think you're having,
Hello?
yes. Hello? What's the name? Hello? So, see, for those of you that weren't here when I said it, right? The script is in a folder, and I have check your chart. Your chart, I've sent it again. If you click that, you're going to see it. You have all of that here, because I'm leaving some gaps so that you can also go look at it. And if you run into any problem, you can always reach out to me or put something, because I haven't really been seeing people put up problems, right? Like actual discussion around issues. Like I told you, all of us are trying to learn, including myself. So put up things like that. There are a lot of people here that are actually very good, with data science already. Put up your questions on the platform and people would answer you.
No, I'm not asking of question. I'm asking of your document, this particular document, if we can get it and reproduce it. That's exactly what I'm saying.
Oh yeah, I think you're having a sound issue.
Yeah, I'm having a sound issue just because of network.
Okay, so what I said is I've put we've already shared it with the class. So check the chat section. I've put the link there so you can download it. It's there. Everything for week 1, week 2, and week 3, everything is there already.
Okay. Oh, that's great.
Okay. Yeah, so
Yeah.
you can see all of this, right?
Okay,
And
that is a Google Classroom, right?
yes, sir.
Okay, thank you
Yeah.
so much.
All right.
I'm
So
going to do that. Yeah.
yeah. So look at hist plot, right? And all of this is your exploratory data analysis. As you go in here, you would see, again, if you see something that doesn't make sense to you, reach out and we can talk about it on the forum, or you can reach out to me directly. And if it's something that I understand, I would explain. If it's not, I will look for people that have the answers, you know. So again, we're going to talk some more about correlation heat maps because it's actually one of those things that is very important. And this is another example of multivariate relationships. And remember, up to this point, all we are doing is, how we get data, how we clean up data, remove all of the things we don't want in the data. And then now we are doing our exploratory data analysis where we are actually mapping things out and looking at how that data is represented. Um, yeah. You can also read up on this. Here is essentially where we are looking. This is mostly for people that are really into statistics because, a lot of natural phenomena, right? You have this regular bell curve, right? And depending on what phenomena or the data that you have, sometimes that data could be when you plot out, the density function or you plot out um plots like this, right? All of a sudden you see that the data is skewed either to the left or to the right. And this is what helps you do that check, right? Which is your KDE plot. You can use all of that. So, and then of course I included, and I hope some of you are reading this book, Python for Data Analysis. For this, to better understand what's going on with what we are doing, you can read chapter 5, 7, and 9. I provided that for us. It's free. It's also on the platform. So for the week 1 and 2, we read chapter 1, 2, and 3. And then for week 3 is chapter 5, 7, and 9. It has its own data set that you can follow, and it has all of that information. And we have all of this here. You can refer to them. Beside what we have here, I also have some data that I put out in Google Classroom, right? You can see all of that data. So we're going to take a little break and then we're going to come back in 12 minutes. So 12,
Okay.
yeah, it will be 3 for a lot of you that are in Western, what do you call it? WAT, West African time. It's going to be 3:50 for you. That's when we come back. And for those in Eastern time, we should be back by 10:50. That's 12 minutes. So take your time. So once you come back, we are going to do a bit of we're going to be working on GitHub, and I would have the graduate assistant lead us in that effort. He is, that's his area of strength. All right. Thank you.